But where in the universe is the Milky Way? A team of scientists gathered data on more than 8,000 of the galaxies that surround us. They mapped each galaxy's position and movement in space. And, for the first time, they've shown that the Milky Way is part of a much larger system of galaxies, a supercluster that they have named Laniakea. The Milky Way is nested in the furthest reaches of this structure, on the outskirts. Superclusters are the biggest structures found in the universe, but scientists have struggled to define where one ends and another begins. To map our home supercluster, a team led by Brent Tully at the University of Hawaii studied the motions of the galaxies around us in unprecedented detail. Even though the entire universe is expanding rapidly, gravity is also at work, pulling against this acceleration. By discounting cosmic expansion, the team worked out which galaxies are being pulled towards us, shown in blue, and which are being pulled away, shown in red. This enabled them to create a map of cosmic flows, the paths that galaxies migrate along, tugged at a tiny pace by the force of gravity. Using this motion, let's take a different view. Each circle represents a galaxy. Again, we can see most galaxies being pulled towards the Great Attractor, in the direction of the arrows. Between the Great Attractor and us, the Milky Way, there's a relatively empty area, a blue void, the tip of the iceberg. This cluster of clusters is merely an appendage of a much larger supercluster, more than 100 times bigger and more massive. But how did the team know how to redraw the boundaries of this cosmic map? Here's our supercluster in black, and a neighbouring structure, Perseus Pisces, in red. Scientists defined the boundary as the points where the flows of galaxies diverge, like water dividing at a watershed. This is where neighbouring structures shear apart. This is the first clear definition of a supercluster. Laniakea means immeasurable heaven in Hawaiian, a fitting name for the vast community of galaxies that we are a part of. So now we know that on the edge of a supercluster called Laniakea,
here in pale blue, we see the outline of filaments where galaxies have collected and are moving together. Black and red galaxy trajectories illustrate flows into distinct gravitational basins. Our location is identified by the blue-red-green arrows on the outskirts of a large supercluster of galaxies. Each small dot is a galaxy like our own. Colors indicate historic associations with separate regions that are dense with galaxies. Our Milky Way galaxy is in a region represented by the green dots that for 50 years has been called the local supercluster, but which is only part of something larger. The present study has connected all galaxies with converging motions, and in doing so, has revealed the limits of the more extensive supercluster that we live in. The separation from neighboring superclusters has become clear.